Hi, welcome to another video, our last video for Year 10. In this video we're going to explore liquid volume. Liquid volume is a measure of how much liquid would fit inside a three-dimensional shape. It's measured in millilitres, which has the unit ml, or litres, which has the unit L. To keep things simple, we basically say 1 centimetre cubed is equal to 1 millilitre of liquid. So a small cube that's 1 centimetre long, 1 centimetre high and 1 centimetre deep will hold 1 millilitre of liquid. Also remember that 1,000 mils or 1,000 millilitres is equivalent to 1 litre. Right, let's get into example 1. A fish tank is a cuboid that measures 30 centimetres by 40 centimetres by 25 centimetres. How many litres of water could the fish tank hold when it is full? Okay, so the volume of the cuboid is base times height times depth. So 30 times 40 times 25. That gives a volume of 30,000 centimetres cubed. Now we remember that 1 centimetre cubed is equivalent to 1 millilitre of liquid. So if it has a volume of 30,000 centimetres cubed, it has a capacity of 30,000 millilitres. Finally, let's remember how to change millilitres into litres. To change millilitres into litres, we divide by 1,000. So 30,000 divided by 1,000 gives a capacity of 30 litres. The fish tank can hold 30 litres of water. Example number 2. The container below is to be filled up with lemonade using 335 millilitre cans. How many cans are we going to need to fill up the container? Well, it's a cuboid, so to work out the volume of a cuboid, once again we go base times height times depth. And that gives us a volume of 12,500 centimetres cubed. We once again remember that 1 centimetre cubed will hold 1 millilitre of liquid. So if it has a volume of 12,500 centimetres cubed, it has a capacity of 12,500 millilitres. Now, how many 335 millilitre cans is it going to take to fill up a capacity of 12,500? Well, let's work out what 12,500 divided by 1 can, which is 335 mils, and that'll give us 37.313438284. We're going to round that sensibly up to 38 cans. We have to round it up, otherwise we won't have enough lemonade to fill it all to the top. Right, example 3. A circular swimming pool has a diameter of 4.2 metres and the water comes up to a height of 1.6 metres. How much water will the swimming pool need? Well, we're going to work out the volume of the swimming pool. It's a circular prism, so we're going to go pi times radius squared times height. Well, these are the numbers we're going to substitute in. Let's take a look. The 1.6 metres, we're timesing that by 100 to get 160 centimetres. The 4.2 metres is the diameter. And we need to do a couple of things. We need to first of all halve it to get 2.1 metres, which is the radius. And then we're going to times that by 100 to get 210, which is the radius in centimetres. Right, so now let's calculate pi times 210 squared times 160. And we're going to get 22,167,077.76 centimetres cubed. We remember that 1 centimetre cubed is 1 millilitre of liquid, so that means this has a capacity of 22,167,077.76 millilitres. Finally, we're going to divide by 1,000 to change millilitres into litres, so dividing by 1,000 gives 22,167 litres of water in the swimming pool. Great, thank you very much for watching.